Hello everyone, I am Unsa.
And I am Irsa.
So today we are going to design a third order bandpass filter on HFSS and its simulation using Waveguide. So let's start. So here I have opened up my software, so I'm going to design my third order bandpass filter in such a way that first I will make a box and define its dimensions. Like let me do it x1, then y1 in millimeters and h1 in millimeters. Okay, then moving towards fit all command. Perfect. Now I will create another box. That box will be inserted inside this first box, so that will be our first band pass filter. Then in the same way we will create a second band pass filter and then third band pass filter, and then we will unite these all three boxes. Let me define dimensions. Okay, so here I have created two boxes, or I will say right now a second order band pass filter, but still I haven't defined yet the cylinders. This box will be inserted inside the first box. Let me change the dimensions a little bit. I will write up equation and will define some new parameters in that equation. Here the most important parameter which we have to keep in mind is the unit. So for all dimensions the unit will be same, which I have kept here, and that is millimeters. Now if I click upon my fit all command, or I will also change the design materials. Yes, let me again create a box. So basically we are creating different boxes and then we are defining their dimensions in such a way that a third order band pass filter will be created. Except now again then we will define some cylinders, and then we will assign materials to our boxes and cylinders. Now keep in mind the material for our band pass filter won't be the single one. Rather we will change the materials like ER43 or copper or brass or another one. We will define vacuum. So here I am assigning the material. Okay, done. ER43 and vacuum fit all. So it's a general view. Now I will create a outer box of these all two boxes, and then I will use a unite command in HFSS. So again I am creating another box. I will define its dimensions in millimeters. So here if I will even just write the value of x1 or y1 only 2, not even writing millimeter, so it will change the whole structure of my box. So I have to, wherever I am mentioning the numeric constant values, so I have to keep the millimeter unit also with my numbers. So last but not the least one box I am creating for the third order band pass filter. Okay guys, we must keep this thing in our mind, like band pass filter is basically a filter which allows a specific range of frequencies to pass. In our project right now here, we will be using a 2 gigahertz frequency, so that our filter, we will later onwards see the results, our filter will allow 2 gigahertz frequency response range of frequencies to pass by it. So okay, if I show it to you, my vacuum box is having 3 boxes. I will unite one each of them separately. Unite command. Okay, this has been done, and same will be with the last one. After completion of boxes, now we will create some cylinders. The fit all command is widely used command in our Ansys software, which we use for our filter designing. So you can see here, just I have defined only 2 materials. I have assigned 2 materials to my project, like only vacuum and only ER43. The inside boxes are made up of ER material and the outside boxes are made up of vacuum, a type of waveguide. It is acting like. So Ansys is a very large software, so sometimes it takes time to load, so a bit patience is required while using this software. Okay, now I will be creating a cylinder. So we'll be assigning dimensions to my cylinder. Again, I will keep the millimeter same dimensions. Okay, apply. Okay, so it's been inserted. Same I will do for the another box. So basically these cylinders plays a pivotal role in our bandpass filters. These are used for input and output channels. Again I will create another cylinder. I am defining the dimensions. Here I can see the different parameters by going into HFSS and its properties. So another cylinder has been inserted inside my first cylinder. If I could show it or make it visible, more visible or transparent. Yes, I hope it is visible and clear to all of you. The same cylinders will be creating on the right side. Let me create that. I will write the same dimensions as I have done for the previous one, so that these both will be mirrored to each other or symmetric. Basically, in our third order bandpass filter, we can change our center frequency and bandwidth, and it could be all be adjusted according to the application requirements. Let me create another cylinder. While designing the third order bandpass filter on HFSS, we must keep in our mind the main function of a third order bandpass filter, or even any bandpass filter. It is basically, it amplifies a specific range of frequencies while reducing or eliminating some unwanted frequencies, and it has wide range of applications, like it includes in audio processing, and then in communication systems, also in signal analysis and instrumentation and measurement. So here you can see I have created my both cylinders. If I could zoom it or fit all command, yes, then now our third order bandpass filter is about to ready, except I haven't created a type of windows. I can say yes, I have to create those windows, and before those windows I have to assign the material to my cylinders. So I am assigning copper to my inside cylinders, these vertical ones, both. Yes, this cylinder one, I will assign the material. Okay, apply. Okay, done. So right now we are having three different materials: copper, ER43 and vacuum. Perfect. Designing any filter on HFSS is not much difficult. Rather, guys, I would say it is easy to make, but a little bit information and practice is needed to design filters or even microstrip antennas and filters. We can design many things on the software, and it is very easy to use. Let me find uh, basically I have to do excitation for the upper face of my cylinders. I have to block excitation. Let me check it. And I am creating windows. I will create basically 4 windows. Those windows will be symmetric to each other, or rather I will say the mirror to each other. So I will define dimensions for my windows also. Let me define. And again I am saying that we have to keep in our mind that the unit, like it can't be like somewhere else millimeter and somewhere else we are writing it as inches or meters, then we will be having difficulties, right? So keeping in mind these all difficulties, and so we have to take all the millimeters dimensions, same dimensions, either millimeters, either inches, or something like that. Then I will assign the material to my first window, and as I have said earlier that a little bit heavy software is this HFSS, so sometimes it gets a bit hanged, so we should have some patience for this. Like right now I am having my patience. So it's working. Let me define the dimensions for my another window. Okay, so last but not the least one window is remaining. So these window will be mirrored to each other. So I am creating my last but not the least one box. Then later onwards I will do some analysis setup. I will assign a cutoff frequency. Again I will assign the material. Okay. And then okay, and it is about to simulate. Okay, it's perfectly designed. So only the analysis part is remaining, so we will do the analysis setup, and then in last we will just create a plot for our figure, and where we will see our response. So basically, while designing a third order band pass filter, it simply involves our 7 steps. The first one was model creation, then excitation setup, then frequency sweep, where we have to define our frequency, and we will define it as 2 gigahertz, then boundary conditions, and simulation run, and then post processing, in which the simulation is complete and we can just analyze and visualize the results for plotting S parameters. So here, just in analysis setup, we are going to define the frequency. Before analyzing anything, we must keep this thing in mind, that we have to run our project first, so that if it is showing any error or any issue in our model creation, we could resolve it as soon as possible before simulating our results. So let me do another setup, 2 gigahertz frequency. Okay, and I will create the plot, which should be linear count. Okay, and let's wait the results come. So this is the S parameter plotting, but wait, let me do validation check. Oh, okay, it's perfectly defined, everything is perfectly checked. So analyze all, yes. So you can see in the right bottom side of our window, it's getting loaded, the green signals, it's getting loaded. We will get our desired response. So this is our third order band pass filter. It's being ready. We have defined 4 types of materials. We have assigned 4 different materials, ER43, copper, brass, and vacuum. And we have now clicked on simulation button, so it's getting simulated till we get our results. I have united these boxes. So these were initially there were 3 different filters, single filters, first order. So the later onwards I did easy. I have done excitation also. We have done excitation. So no, this is not our required as such response. So again we will wait till this blue cursor is being finished. And when our loading is completed, okay, so this is our final response. If we could visualize this, see guys, this is showing us 2 gigahertz frequency, which was our desired frequency. So keeping in mind that when we are evaluating this filter's passband characteristics, we can get even gain, selectivity and many different performance in this frequency domain. So this was our third order bandpass filter.